Welcome to scientific notation. So we'll be taking notes on this today. This PowerPoint does not perfectly match your notes, and so your notes will be filled in by what I say, not necessarily what's shown on the screen. I'm going to show you a few things before we start filling in the notes, just so that you can get a grasp of what's going on visually for the numbers. So the first thing I want you to know is this number right here. Maybe you've seen a number that looks like that before, or maybe you haven't, but by the end of today, you will be very familiar with that and you will more than adequately be able to tell me what that means and do math with it. So scientific notation. So again, this is not directly in the notes, but I just want you to note that scientific notation is a way of writing very large or very small numbers that are hard to express in decimal form. And what we use this for in science is it's largely used for the small numbers, chemistry and biology, when we're talking about the amounts of chemicals in a certain amount of fluid, or maybe the weight of a chemical. If we're talking about a small amount, it's going to be a really small weight. Or if we're talking about physics, we can be talking about huge distances, or maybe masses of a star or a planet. And these numbers start being so large that it just takes a lot of time to write all these zeros. And then the same thing, if I wanted to say how many molecules are in so many grams of a substance, well, those molecules are so small that that number is actually exceptionally large, generally coming with more than 20 zeros. And to have to write them all out will make your eyes cross, make your hand cramp, and make you tired of whatever you have to do before you even get started, just because you had to write that big number. And so this is a way to really quickly and very efficiently note a large or small number. So in your notes, the very first blank says that scientific notation is used to express very large and very small numbers so that calculations will be made easier. So this makes calculations easier, and we'll talk about doing math with these numbers toward the end. But first I want to show you how to handle them and recognize them and treat them as you go. So this next blank, or this next statement here, says that a number is written in scientific notation if it is of the form c times 10 to the n, where c is a coefficient. That's what c stands for, coefficient, which is a number, or a number that you multiply a variable by, and it must be between 1 and 10, and that this number n here, which is an exponent, is an integer. So they give you a note here that says an integer is a positive or negative whole number, including 0. So 0 can also be, so it's pretty much any whole number that does not involve decimals. All right, you never want to raise a number to a power with a decimal in it. You're always going to try to do that with whole numbers. So I want you to pay attention right there to the C. It must be between 1 and 10. Now, as we get in there, you're going to very quickly understand why it must be between 1 and 10, because it kind of defeats the purpose if it's less than 1 or greater than 10. So the two examples that they give you in your notes says that the mass of one gold atom is, let's just count the zeros, 3, 6, 9, 12, 15, 18, 21. There's 21 zeros there, and then 3 more numbers. So that's a total of 24 decimal places. All right, that's a hugely small number. Now, the next thing it says is that 1 gram of hydrogen contains, and then if you look again, that's 3, 6, 9, 12, 15, 18, 21, 21 zeros, and then 3 numbers, so 24 decimal places. All right, so when we are dealing with chemistry especially, you can very quickly get a large or a very small number just by talking about certain amounts of atoms or their weights. So scientists can work with very large or very small. So the second blank for number 2 is very large or very small numbers. And then that's why they gave you those 2 examples. All right, so this is a list of things that look like scientific notation. All right, now I say look like because all of them are not necessarily following our rules. So let's quickly scan through these, and I want you to think in your head, because I am going to identify which ones follow the rules. I want to remind you that in order to be in proper form, it must be in the form of c times 10 to the n, where c is a number between 1 and 10, so the coefficient must be between 1 and 10. And this integer here, n, must be a whole number. It can be negative or positive. All right, first let's just check all the n's. All right, let's check all of those exponents and see if we have anything that's got a decimal or that does not fit our requirement. So we've got 5, negative 16, negative 9, negative 6, 1, 9, 23, 7, 0, negative 22, and 8. Looks like all of our exponents are going to be pretty good, so we know that that's not going to kick any of these out. But let's figure out, based on our coefficients, which one of these are in correct notation. So here we have 2.35 times 10 to the 5th. This looks like it's in correct notation. We've got a number between 1 and 10. Here we've got 2.1203. This number is between 1 and 10. 5, a little bit more simple, but it still follows the rules of between 1 and 10. Now let's look at this next one. Hopefully you've noted that this is a number that is not between 1 and 10. And in order to put it in the right form, we're going to have to move the decimal point so that we can make this number between 1 and 10. So if I move the decimal point to the right, it would make the number larger and push it further from our goal. So here I'm going to have to move our decimal point to the left. This then gives us 4.59. Now, I want you to understand what this negative or what these exponents mean. These exponents tell you how many times to move the decimal in order to get the decimal number, so the fully written out number. If it is negative, this suggests a small number and you will move the decimal to the left that many times. If it is a positive number, that suggests it is a larger number and you will move the decimal to the right that many times. I'm not going to practice that here. I just want to point that out. You'll see that again in just a few. So the next one is 3.214 times 10 to the first. Everything checks out here. C is between 1 and 10, and that's an integer. 10.3. Even though it's close, this is still greater than 10. So we would have to move our decimal to the left and turn this into 1.03. The next item we have is also going to be incorrect, as we have 73.8, which is definitely greater than 10. And so again, we would move our decimal point to the left just that once and get 7.83. It can be negative. This is one of the only negative numbers other than this one down here, but this can be a negative number. It just has to be between 1 and 10. 6.09, that checks out for me. That's between 1 and 10. Now we've got 12. So this is above 10. And so what I'd have to do is move that decimal to between the 1 and 2, and this will become 1.2. We've got 1.9 here, and then finally negative 4.89, which also checks out. So the ones that didn't check out were 12, negative 78.3, 10.3, and 45.9. And all I did in order to fix it is we're going to move the decimal point, and that will end up changing your exponent because you moved the decimal. So you're going to have to account for that there. We'll talk about that in just a few. So for how to use scientific notation in your notes, you're going to see it says in scientific notation, a number is written as the product of two numbers. That is where you're going to put this equation here, c times 10 to the n. And I want you to give this caveat here where c is between 1 and 10 and n is an integer. So you're going to copy that, copy, and then you're going to copy this statement as well. This will allow you to remember that it is some coefficient between the number 1 and 10 multiplied by 10 raised to some integer power. So that means you're going to either multiply or divide by 10 a certain number of times, thus moving your decimal point that many times, And whether it's positive or negative tells you whether the number gets larger and you multiply, or whether the number gets smaller and you divide. Just to remind you, when you multiply something by 10, hopefully you know this, but if I multiplied 4 by 10, it becomes 40, and I add 1 0. If I multiplied it by 10 twice, it becomes 400, and I add 2 zeros, which technically would be moving the decimal point to the right twice. If I divide by 10, I end up pushing that number further toward being a decimal. And I'm going to add zeros in front of it once I get past that number. And we'll see examples of that here in just a few. So for example, the number 4,500 is written in scientific notation as, so we're going to quickly share a Smart Notebook so I can write that. So the number 4,500 is written in scientific notation as, well, let's see. What numbers can I pick and put a decimal between to make this between 1 and 10? Because I'm going to need C times 10 to the n. All right. Well, I'm looking here. 45 would be too large. 450 is getting even larger. So I'm going to have to say 4.5. So I'm going to have 4.5 as C. Now I'm going to multiply that by 10. And let's see what this looks like. All right, so if I put a decimal right there, I'd have to move the decimal point 1, 2, 3 times, and I'd have to move it 3 times to the right in order to get this original number. So this right here will be 4.5 times 10 to the third. So that is the example there. So that is how you would write your 4,500 in scientific notation. The coefficient is right here. I'm going to underline it in red. That's your 4.5. The coefficient must be a number, again, between 1 and 10. It has to be a number between 1 and 10. The next blank says the power of 10, or exponent in this example, is 3. The exponent indicates how many times the coefficient must be multiplied by 10 to equal the original number of 4,500. So if I multiplied 4.5 by 10 once, it would give me 45. Multiply it by 10 twice, it would give me 450. Multiply it by 10 3 times, and I get 4,500. There we go. So somebody sent that answer in the chat. So that's awesome. So now we are on to rules to remember. I'm going to scroll back down here. And we're going to be dealing with this in just a second. So we're going to practice this together in just a few. So rules to remember A says if a number is greater than 10, the exponent will be blank and is equal to the number of places the decimal must be moved to the blank to write the number in scientific notation. So if a number is greater than 10, you're going to have to multiply that coefficient by 10, which means you need a positive exponent. So the first blank for A is positive, and that means you're going to move the decimal place that many times to the right. So if you have a positive, so if we go back up to these examples right here, let's just look at the first, 2.35 times 10 to the 5th. That means that you're going to have a larger number, and you're going to move that decimal point to the right 5 times. Then B states if a number is less than 10, meaning smaller than 10, the exponent will be negative and is equal to the number of places the decimal must be moved to the left to write the number in scientific notation. So if we look at the very next example, we've got 2.1203 times 10 to the negative 16th. This states to me I will have a very small number, and there will be 15 zeros. The reason I say 15 is because one of those moves to the left gets it right there, and then the next 15. So that's 5 sets of 3. That's a lot. It's a really small number. Then C says, a number will have an exponent of 0. So we actually don't have one mentioned in the first few, but we have one right there. A number will have an exponent of 0 if the coefficient is the final answer. All right, so if the coefficient is the final answer. So let me show you what that means. So it will have a coefficient of 0 if the coefficient is your final form. So right here, let's just say my original number was 2.3. All right, now if I multiply 2.3 times 10, what would that give me? Because that would be 10 to the first. That's 1 time. That would end up giving me 23. But that's not my original number. I want my original number to be 2.3. So if I don't want to move my decimal point, how would I signify that I don't want to move that decimal? It needs to move 0 times. So I would need this to be 2.3 times 10 to the 0. All right, this works for 2 reasons. 1, this 0 tells you you're not moving your decimal point. It moves 0 times. So that's the first. But the real reason is, if you know anything about raising a number to the 0 power, this actually makes this number 1. Anything raised to the power of 0, even infinity raised to the power of 0, becomes 1. And when you multiply a number by 1, you get the number again. So that's what it means if the exponent is 0.
Mr. Sellers?
Yes.
Can you repeat the blank for number for letter C? I kind of.
So a number will have the exponent of 0 if the coefficient is the final answer. So in the example I've given here, I want 2.3. That's my actual number. And I only will have that exponent of 0 if that coefficient will not change. So if your coefficient is your final answer, then the exponent will be 0. You may see these, but I will never assign one for you to do like that because it's kind of confusing. All right, we're going to switch back to our PowerPoint. Now, it says to write a scientific number in, or to write a number in scientific notation, and it's got 4 blanks there. So first, you identify your coefficient. So that first blank is identify the coefficient. Remember, it has to be between 1 and 10. So you might want to put that in parentheses. So first, identify the coefficient. So those are going to be the non-zero numbers that are in your original number.
Sellers?
Yes.
What did you say to put in parentheses again?
Say that one more time.
I said, what did you say to put in parentheses after we say identify the coefficient?
That the coefficient must be between 1 and 10. So rules to remember is that the exponent will be positive for A, and that means you're moving to the right. And an exponent will be negative if it's less than 10, and that means you're moving the decimal to the left. So your second step is to determine whether your number is greater or less than 10. So determine if your original number is greater or less than 10. So the first thing you do is you find those first non-zero numbers, which are your coefficient. Then you determine whether your number is greater or less than 10. All right, so I'm going to give you an example. Do this one in blue. All right, so right here I have 373,000, and your first step is going to be to identify your coefficient. So your coefficient is going to be you're going to take that first non-zero number you find, and you'll put a decimal after that, and identify all non-zero numbers right there. All right, so you're going to identify that these are the numbers you want for your coefficient. That's step 1. Then you're going to identify whether your number is greater than or less than 10. This is greater than 10. That's step 2. Step 3 is to count the number of decimal points you would have to move in order to get, so just to show you, this is where the original decimal is, at the very end of the number. You're going to have to determine the number of jumps it takes to get to your coefficients form. All right, so in order to do that, let's count 1, 2, 3, 4, 5. All right, so in order to get from 3.73, which is my coefficient, to 330 or 373,000, I'm going to have to move my decimal 5 times. All right, so I know based on the fact that it's greater than 10, it means it's going to be a positive number. And I've now counted that it's going to be a 5. So I know it's going to be a 5. And then, so that's step 3 is to count the number of jumps. And step 4 is to put it all together. So step 4 is take your coefficient. I know that's a little bit of rough. Multiply it by 10. And then put in that positive coefficient, or put in that positive integer. All right, let me give you the opposite example. So I'm going to do this one in red and highlight in blue. So your first step, so we're going to have 0.000026. All righty, and that is going to extend this page a little bit. Now my first step is to identify my coefficient. So I'm going to try to identify my first non-zero number. That's right there, that 2. It must be between 1 and 10. So I'm going to put my decimal point right there. And so I'm going to make that blue. So that's going to be my new decimal. So I'm going to write this down. That's my first step. My second step is to identify whether this original number is greater than or less than 10. This number is definitely less than 10. So that lets me know that I'm going to have a negative exponent. All right. But now I have to figure out with step 3 what that exponent is. And so I'm going to have to count how many times would I have to move from my coefficients form of 2.6 to get to the original form right here. So we're going to count 1, 2, 3, 4, 5 jumps. So then I'm going to put it all together. It's going to be times 10. And I determined it's smaller than 10, so it needs to be a negative. And then we've got a 5. And this is your 4-step process. Identify coefficient, determine whether the original number is less than or greater than 10, count the number of jumps, and identify your exponent, and then you're going to put it all together. So the step where you're identifying whether it's greater or less than 10, this is where you're actually coming up whether it's positive exponent or negative exponent. So we're going to switch back to our PowerPoint. So those are your 4 steps. Now we're on to the back, and oh my goodness, practice problems. What in the world are we ever going to do? We're going to try a couple. I'm going to leave you to try. I'm going to suggest that you finish the rest of them. We're going to do the first 2 on both columns. Okay? Sound like a plan? We're going to practice those first 2. But first I want to show you these. So right here, we've got decimal notation going to scientific notation, which is what you're going to see in that first column on the practice problems. And that means you're going to have to first identify what's your coefficient. They've already identified it for you with the star. The star is already where your decimal needs to go. And so your coefficient for this first one will be 1.23. For the second one will be 4.5. And for the third one, we will have 6.78. So this lets us know that's our coefficient. That's step 1. Now you identify whether it's greater than or less than the number 10. They are all greater than 10. So we're going to have a positive exponent. Now you're going to say, in order to get 1.23 to this number, how many times would I have to move the decimal point? And we know it's greater than 10, so it's going to be a positive number. So we're going to identify our exponent here. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this would look like 1.23 times 10 to the positive 11th. Let's try it with 45 million. We've got greater than 10, so it'll be a positive exponent. Let's determine what number that will be. 1, 2, 3, 4, 5, 6, 7. This will be 4.5 times 10 to the 7th. Then right here, our biggest number yet. So here, that's the millions, that's the billions. This is 67,800,000,000,000. That's a big number. All right, that's my net worth. Just kidding, I'm not worth that much. All righty. Now we're going to count to see how many times I'm going to have to jump to get this number from 6.78 to 67 trillion. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 jumps. This will be 6.78 times 10 to the 13th. Now we're going to do the opposite way. So you will just reverse. So now you're going to identify your integer right here, your exponent, and you're going to identify whether that's a bigger number or smaller number. It looks like everything here is greater than 10, so you're going to be moving all your decimals to the right. So in this one, you're going to move it 3 times to the right. So I'm going to go here. I'm going to move that 3 times, and that gives me 1 extra 0 after the 2, and this becomes 7,820. Here, I'm going to move my decimal 8 times to the right. So it'll be 1, 2, and then 6 zeros, so that's 304 million. And then here, I'm going to move my decimal to the right 4 times. So that's going to be 1, 2, 3, 4, that's 50,000 as our answer. If this were an interactable smart document, which is what this is supposed to be, I would be able to move the star. I'd be able to take this off and show you the answer. It's not an option. I'm telling it to you. All right, so now that we've seen that, let's try the examples that we have, practice problems. And I'm going to ask that at some point before the test next week that you try those problems. All right. So we still got, it's looking like we've got about 45 minutes left in class, so we're making good time. So we're going to erase this. And we're just going to practice those problems really quickly. So we're looking at number 1.00012, and it's asking you to put that in scientific notation. So remember, step 1 is to identify your coefficient. What's our coefficient here? Somebody help me out.
1.12. I mean 1.2.
1.2. So it's going to go right there. So now that we've identified our coefficient of 1.2, we will write that down. Now we identify, is this number greater than or less than 10?
Less than 10.
Less than 10. That's going to tell me negative exponent. All right, now what's our negative exponent? We're going to have to count jumps. So that's going to be 1, 2, 3, 4. So it's going to be times 10 to the negative 4. All right, let's try that next number that they give us. All right, we've got 1,000. All right, let's try out 1,000. All right, so we've got 1, 0, 0, 0. So first, what's our exponent? Or excuse me, what's our coefficient?
1.
1, exactly. That's between 1 and 10. So it's going to be 1. So I'm going to have 1. You can have 1.0 if you'd like, or just 1. And then that's going to be times 10 raised to something. Is this number greater than or less than 10?
Greater than 10.
Greater than 10, that tells me positive exponent. All right. Now, how many jumps? 1, 2, 3. And that tells me positive 3. So 1 times 10 to the 3rd is 1,000. All righty. So I'm going to erase these. We're going to try the ones that are going in the opposite direction, where you're given scientific notation, and then you have to expand it to the decimal form. So we've got 4.9 times 10 to the 2nd. All right. So again, you're going to go in reverse. You're going to say that it's going to be a bigger number than 10. So, you're going to be moving your decimal to the right 2 times. And so you're going to write 4, 9, And again, you're going to move that 2 times to the right. So that's going to be 490. Put that decimal there. And this is your new number, 490. Okay. I find this easier than going the other way around, which is why I started with the hard stuff. All right, let's look at this next problem of 3.75 times 10 to the negative 2. All right, first thing I'm going to notice is that my exponent is negative, which means I'm moving my decimal point to the left, and it tells me I'm going to move it there twice, or move it in that direction twice. So that will be 1, 2. We're going to add a 0 there, put our decimal point right there, and our new answer is going to be 0.0375. And so this is our new answer. So there are a total of 18 here. I'd like you to try them all. It's really good practice. You will be tested on this next week, and you'll have an opportunity to practice this on your study guide that we'll be going over today. So just be aware, the more practice you get, the better you will be at it, and the easier it will be to recognize what to do if you see it in the future. All righty. So now we're going to move to the last section, and that's how to use, I'm going to just stay right here on this so I can actually write it out, and it's how to use multiplication, division, addition, and subtraction. There's only 3 rules because addition and subtraction are going to be the same. So scientists must be able to use very large numbers and very small numbers in mathematical calculations. As a student in this class, you will have to multiply, divide, and subtract numbers that are written in scientific notation. I won't make you do it often, but you will need to be able to do it, so we have to teach you what to do. So the rules are for multiplication. All right, so for multiplication, they've got a sample problem, but I'm just going to, quickly let you know that it is not as complicated as it seems. So for multiplication, the step is you multiply the coefficients. So I'm going to write this in shorthand, coefficient 1 times coefficient 2. All right, so coefficient 1 times coefficient 2. And then it is times 10 in 1 plus in 2. All right, so let's actually look at what that means. So I've gotten it kind of very variable here. So let's explain that. So you're going to multiply the 2 coefficients as if they were just numbers. So that one should come pretty easy. That's just real quick. And then you're going to add the exponents together because it becomes a larger number when you multiply 2 large numbers. So this number should go up and that number should go up. So let's look at what that looks like for our sample problem. So for our first coefficient, we have, okay, so the 2 numbers, I'm just going to write in red over here, or excuse me, black. 3.2 times 10 to the negative 3rd multiplied by 2.1 times 10 to the 5th. So we're going to multiply our 2 coefficients. All right, so does anyone have a calculator out? You should go ahead and try to calculate this out. So I'm going to type this in really quickly. 6.72. Got it on the cuff. All right, so we're going to have 6.72 as our new coefficient, 6.72. It's going to be multiplied by 10. And now when we add these coefficients, I want to remind you that when you add a negative number to a positive number, it's the same as subtracting. So 5 plus negative 3 is equal to what?
2.
2. There we go. So this new number is going to be 6.72 times 10 to the 2nd. All right. Now I'm going to erase the example. I'm going to keep that base form up, and I want you to compare what multiplication looks like compared to division, because division is the opposite. It's the opposite opposite operation. Sorry, my mouth wouldn't work. So it's going to be C1. Get you to mute your mic for me. I'd appreciate it. It's going to be C1 divided by C2 multiplied by 10 raised to the N1 minus n2. All right, so let's look at what this means. This means you're going to divide the coefficients and subtract your exponents. And you'll know which one to subtract and which one to divide because it'll be the first one to show up. Just like in regular math, like if I said 12 divided by 8, you would put 8 under 12. All righty, so let's look at the examples they give us. So they've given, for this one, 6.4 times 10, excuse the writing, the mouse is kind of fighting me, to the 6 over 1.7 times 10 to the second. All right, so the first thing you do is you divide those first two coefficients. So 6.4 divided by 1.7. Do we have an answer for that?
3.76.
3.76. So that's my new coefficient. This will be multiplied by 10. And now I'm going to subtract my exponents. So 6 minus 2 is
4.
4. There we go. All right. So just to let you know, this right here says 6,400,000 divided by 170 is equal to 37,600. Is that right? Yeah, 37,600. And if you actually plugged those big numbers in and divided it out, you would get 37,600, and you are more than welcome to test that out. This is making it much quicker than typing the whole thing out. You can just divide that real quick, and then you can probably do the subtraction in your head. All right, so I'm going to erase this example. Now, I wrote this weird, and you can write it like that if you want, but what you're going to say is you multiply coefficients and add the exponent. And then for division, you're going to divide the coefficients and subtract the exponents. I'm just going to draw a line between that. And we're now, let me undo that last line. That's a little bit better. All right, we're going to roll it down here, and I'm going to go to the very last rule. The very last rule is addition and subtraction. So here, there's no shorthand I can give you because it's not quite as simple. It's a little bit weird. So the addition and subtraction, you have to bring the smallest of the two to the same exponent as the other. In order to add and subtract anything that has exponents, they have to be the same exponent. So let me give you the example that they give. So they give 5.8 times 10 to the third. And it doesn't say plus or minus, but I'm going to add plus 2.16 times 10 to the fourth. All right. So what this is telling me is that I've got 5,800 plus 21,600. So I should expect a larger number. But the thing is if I just try to add these together, if I just added 5.8 to 2.16, the exponents don't match and these don't have the same values because that's 5,000 and that's 21,000. Okay, so that's going to be off. So what are we going to have to do in order to bring this to the right number? So what I always say, yeah, so you're going to have to change the exponent. But if you change the exponent, you're also changing your coefficient. Because just to give you an example, with 5.8, if I want 5.8 times 10 to the 3, so that's going to be technically 5,800. That's what times 10 to the 3 means. If I want that written in times 10 to the 4, which is what my larger number is, I'm going to have to move the decimal right there because watch, when I have that new decimal here, that is a 1, 2, 3, 4 jump. And so my new thing will be 0.58 times 10 to the fourth. So what this generally means you will do is you will end up decreasing the size of your coefficient to increase the size of the exponent. Does that make sense? you're going to bring the smaller of the two exponents to the larger number. Because if I did it the other way around, you can always go the other way around and take this to 3, which means moving that right there, and that becomes 21.6 times 10 to the 3. That is also an option. Either way, if you decrease the exponent, you increase the coefficient. If you increase the exponent, you're going to decrease the coefficient. But regardless, you're going to have to change the coefficient so that you can bring one of the exponents to the other option. So let's just look at this right here, because I like this, and we can look at it the other way around in just a second if you'd like. So we're going to have 0.58 times 10 to the 4th, and the exponents don't do anything, all right, plus 2.16 times 10 to the 4th. These exponents are the same, so that's just, that's going to be it. And it's going to be 2.16 plus 0.58. So that'll bring it up. If I add the 0.5, that'll bring it to 2.66, and then the 8 there will bring it to 2.74. So 2.74 times 10 to the 4th. Now, if you did it the other way around, and you took your 2.16 to 221.6, then what you would have is you would end up having 21.6. Let me scroll down just a little bit. You'd have 21.6 times 10 to the 3rd plus your original 5.8 times 10 to the 3rd. And then you're just going to add, and you'd get 27.4 times 10 to the 3rd. Now, I want you to look at what the issue here is. Is this in proper scientific notation?
No.
No. So the issue here is that we need a decimal point between the 2 and the 7. So even if you do it this way, you're still going to have it in this original form, which is why I suggest you bring the smaller number to the larger number. Because if you do it the other way around, you're going to have to add in an extra step at the end. All right? So just be aware that that first step I showed you is probably your best bet. And that's scientific notation. That's it. That's all the rules we've got for it. And the rest of it is just practicing. All right?